Hello Year 13. So this is a video on the modulus function, sketching and solving with the modulus function. So I suppose I ought to start by introducing the modulus function. Now this is simply two straight lines. This is how we denote the modulus function. Let me just go back to the normal pen. But two straight lines around a number or a letter or some kind of mathematical expression. Now all the modulus function does is make anything negative positive. Yeah, it's a very positive function. To positive numbers, it does nothing at all. It just leaves them alone. And so, for example, 3 minus 7, taking the modulus, well, that's just going to be 4, because that equals minus 4. At the end, you take the modulus, makes it positive, becomes 4. Now, it sounds like a really simple function at first. You think, how can this cause any problems in maths at all? How can this be remotely confusing? Well, let's think about how we would sketch y equals modulus of x first. We'd have a graph, so let's just draw some axes on. And when x is positive, the modulus function does nothing at all. So it's definitely going to be just like y equals x whilst x is positive. But the problem is, the second that it's negative, let's say we had x is minus 1, normally this function would keep going down here, yeah? Like that. It would just be y equals x. But now, because we're dealing with a modulus, x is allowed to be negative, but y will immediately be positive. So rather than going through the coordinate, for example, minus 1, it's actually going to go through the coordinate minus 1, 1, minus 2, 2, minus 3, 3. And so it bounces up like that. And like I say, draw a little table of values if you're wondering why, with x and y, and you can see that when x is minus 2, y is 2. When x is minus 1, y is 1. When x is 0, y is 0. And then for the positive cases, it's going to be exactly like y equals x, so on and so forth. So anyway, we get this funny V shape. Now, so far so good. It can't be too complicated, can it? Well, sketching actually does get the better of people. It really does. And it all depends when the modulus function happens. So if we take, I'm going to call these bouncers first. And they're all going to have something in common. Bouncers are all of this form, y equals the mod of a function of x. In other words, we say mod or modulus. Let me just make that clear. In other words, the modulus is the last thing to happen after you've done the rest of the function, applied the rest of the function to x. So they're all going to be of this format. And let's take a simple one first. Y equals mod of 2x minus 1. Yeah? So the modulus is the last thing to happen. And what that means is y can never be negative. Now, I hope you'll see in a second why I call these bouncers. It's because of what happens when we try and sketch them. Now, my advice when drawing bouncers, and in some ways I take a similar approach when drawing the faces as well, you'll see what I mean in a second. If I was just going to ignore the modulus first, and that's what I suggest you do, that's my advice. If you just ignore the modulus for a second, you could draw the line y equals 2x minus 1, and I hope it won't surprise anyone to realise it's got a gradient of 2, and it goes through minus 1 on the y-axis. Sorry, I should be labelling my axes as well. That's quite a bad habit I have. It's also going to go through a half on the x-axis, and just like any sketching, you should label whenever it hits the x or y axis. So that point is at a half, yeah? Now, actually it doesn't look like that, because sure, okay, whilst x is bigger than a half, you're going to get a positive number out of here, and it's going to look exactly like the line y equals 2x minus 1. But the second you use a number less where x is less than a half, you're going to get a negative value. And those negative y coordinates, like for example minus 1, let's take minus 1 down here. When x is 0, you get minus 1 within the modulus, but the modulus makes it positive 1. So it should actually be going up there. Now, why is that? Well, it's because it's a bouncer. And this part, which I drew deliberately, and I would suggest you do too, as you're constructing what the graph looks like, draw just a normal function, but then make it bounce off the x-axis, because y cannot be negative for the bouncers. So it's actually going to look something like that. Like I say, it makes a lot of sense because all your negative y coordinates should become immediately positive at the end, and so that has the effect of bouncing it off the axis. So that's what the modulus of 2x minus 1 looks like. Let's do a couple more. Let's try, and let's go back to black. These are all part of the bouncers category, by the way. Y equals the modulus of sine x. Or let's do cos x, actually. It'll be more fun. Now you might think, oh, this seems a bit complicated. Don't worry. It's not too bad, actually. As long as it's a bouncer, it's not too bad. Now, if you're going to sketch this, once again, I would advise you to just draw cos x like it normally looks like, as a wave going up again, up and down and up again. But at the end, recognize, because the last thing you're doing to this is making y positive, that has the effect of bouncing all the bits where it goes into the negative y coordinate quadrant. It bounces it off the x-axis. It will always bounce it off the x-axis. So what we're going to do is we're going to get our little rubber out. We're going to rub those off and we're going to bounce them. Yeah, bounce them up there. Boing. So it's like a bouncing ball, the path a bouncing ball would take. Boing. And there we go. Now do make sure you've got all your intercepts on. I think that happens at pi over 2. That will be at 3 pi over 2. That will happen at minus pi over 2 and minus 3 pi over 2. And it goes as high as 1 because it's cos x. And there we go. We've got y equals modulus of cos x. Let's try one more bouncer just to round it off. 1 second. Let's try y equals, what could we do? What else could we do? Why not one where it doesn't really bounce, but it's still a bouncer? So can I do 1 over x minus 1 modded at the end like that? Yeah. Now, this is the thing. I call them bouncers, but perhaps bouncing is the wrong way of putting it. It's actually a reflection of any part of the curve which is in the third and fourth quadrants. That's the quadrants where y is negative. We're just reflecting them in the x-axis. That's what's really going on. And you'll see that if you consider this one. Now, when we're drawing this curve, it's going to have an asymptote at x equals 1, because you always have asymptotes whenever you divide by 0. So let's have a little asymptote at x equals 1. Sorry, I'm not very good on the whiteboard. Let's just do it in a different color, the asymptote. We'll do it in bright yellow and then do it in a straight line. So there we go. We're going to have an asymptote down there. Maybe I could have changed the line style and been a bit flash. Okay, and otherwise it's just going to look like 1 equals x, yeah? Because 1 equals x, y equals 1 over x. Because y equals 1 over x has been moved 1 to the right if you suddenly try and draw 1 over x minus 1. So at the moment, I'm just trying to draw y equals 1 over x minus 1. Forget the modulus. Just draw that. And it should look something like that. And by the way, when x is 0, y is minus 1. So it's going through minus 1 down there. Now, at the end, though, we're making all our y coordinates positive. That's going to have the effect of reflecting that bottom bit of the curve up there. And so the final answer should look something like that. I'll just rub that out very carefully. There we go. And that's what the bouncers look like. Now, what about another category, which I call the faces? Faces. Okay, so faces I would describe like this. I call them faces. That's not a mathematical term. It's just my term. Okay, and these are functions of the form y equals f of the modulus of x, yeah? So this time, the first thing we do to x is we make it positive, yeah? Let's try, for example, y equals 2 mod of x plus 1, yeah? So this time, the modulus is applied to x immediately. Now, this is a different situation. Yeah, for a start, oh, can I make that? Can I do something? Can I change this? I apologise. You know what I'm like in lessons. I suddenly have an idea about changing the question I've asked you. Let's do that one. 2 mod of x minus 1. Okay, if we do this one, it's not going to work the same as the bouncers, because y can be negative this time. For example, if x is 0, 0, with apply modulus to 0 and you just get 0, times it by 2 you still get 0, and then you're taking away 1 at the end, so you can get -1 for your y coordinate here. Now, the way I describe these is, once again, just like the other ones, ignore the modulus first. Just draw a graph completely ignoring the modulus, and we'll get exactly the same as before, something like that. But this time, it's not that y can't be negative, y can be. Like I say, when x is 0, y is negative. Basically, the right-hand side of the graph is going to be exactly the same every time for the faces ones. And that's because when x is positive, the right-hand side of the graph, when x is positive, the modulus does nothing. So it's identical to the line y equals 2x minus 1. But the left-hand side of the graph, to the left of the y-axis, well, that should be an exact copy of the right-hand side. Why? Well, because let's say you're dealing with x is a half. You get 2 times a half is 1, take away 1, you get y is 0. Now let's say you're dealing with x is minus a half. Well, the first thing you're going to do is make that positive half, and then you get 2 times a half, again, minus 1, 0. So you should get exactly the same y coordinates on the left-hand side as you get on the right-hand side. Now, what is the result? The result is your graph will definitely have reflective symmetry in the y-axis. Why would I describe that as a face? Well, faces will always have reflective symmetry right down the middle of them, and hence it's a face. Hopefully that makes sense. Let me draw one more to give you an example. One more face. Let's try y equals sine of the mod of x. Yeah? Well, this one, once again, just as I said before, draw it as you normally would. Yeah? Start by drawing it by ignoring the modulus, and then think about what happens to this function according to whether it's a face or a bouncer. It would normally look like that, yeah? But the right-hand side's not going to change, because when x is positive, it's going to be exactly like the graph y equals sine x, because modulus does nothing to a positive number. So what we've got to do, let me go forward there, is just rub out the left-hand side and make sure it's got reflective symmetry in the y-axis. So that's going to make it come up like that and down like that. And so it's going to look like a crazy moustache. Don't forget to put your value so you can see it's bounded between -1 and 1 and pi and 2 pi. Bring in some radians there. Minus pi, minus 2 pi, that over there, and that is what sine of the mod of x looks like. Okay, those are the sketches. Let's talk about solving equations now. Solving very quickly because I have to cycle back to school. Okay, solving equations. This is actually easier than the sketching in some ways. But by the way, for the sketching, can I just tell you what page of the book you can do the sketching on? The sketching is actually on page, let me just look it up. It's on page 17, question 1, and then page 18, question 5. That's where you'll get the sketching practice. You might want to do that before you do the solving. They annoyingly break them up really cleanly into faces and bouncers. I would have rather they muddled them up a bit. Anyway, solving equations. This is really nice. Let's say you've got to solve a linear equation, like solve 3x minus 2, mod of that equals 7. Well, I like this one because I can just, if you like, could I just try and cover this up? Well, I wish I could cover it up with my screen in some way. I don't think I've got anything flash to do this, yeah? Let's just imagine that's not there, the 3x minus 2. Yeah, if I've got mod of the modulus of some mystery number equals 7, well, what goes in here could either be 7 or minus 7. Yeah, and it's 3x minus 2. Well, in that case, I can take this in two directions. 3x minus 2 could be equal to 7, or because this could be positive 7, and a modulus of positive 7 is 7. 3x minus 2 could be minus 7. And that's because minus 7, if I take the modulus of that, it's 7. Yeah, this could basically be 7 or minus 7 in there, because I'm immediately going to make that minus 7 positive, and so I get two different answers. That's going to give me x is 3. This one's going to give me x is minus 5/3. And let me tell you what the graphical interpretation is, because the graphical interpretation is really quite interesting. A sketch of y equals 3x minus 2 modded, y equals 3x minus 2, would look just like this. Oh, let me try and draw a straight line. It would look just like this, yeah? With intercepts at 2, because that would have been down at minus 2, and I think this will be 2/3, because when x is 2/3, y is 0. Why are we getting two answers out? Well, because we're finding where that curve, or V-shaped straight line if you like, we're finding where that hits the line, y equals 7. And what we've found is that it hits the line at 3 or minus 5/3. And sure enough, 2/3 is exactly halfway between 3 and minus 5/3. And that's the graphical interpretation for what's going on here. It's the reason you get two answers out of solving an equation. Let's do another more difficult one, though. Let's do a more difficult one. What should we do? What should we do? Actually, I'm really running out of time because I've got an appointment at 3 o'clock at the school. Let's solve this. Solve, and this is just coming from the exercise. This is exercise 1G, by the way, which is what I'm going to ask you to do. Something like modulus of 1 over x equals 2. Well, you've really got to say, okay, either positive 1 over x, well, 1 over x equals 2, or 1 over x could have been minus 2 as well. And then you just solve normally. So x is a half, or x is minus a half. And you get your two answers. Graphically, it's because mod of 1 over x looks like that. And when you're finding where it hits 2 in two different places. Sorry, that's such an appalling diagram, but it is correct. Half and minus a half. Okay, I'm going to leave it there for the moment, but I'll be popping loads more of these little YouTube videos up. So keep an eye on Google Classroom. There's lots more to come. And please, any questions, hopefully you can see where I'm free. If you check Google Classroom, you can see all the periods I'm free. Try and get in touch with me. I'm eager and waiting and ready to help. Get in touch over Zoom or Skype. Okay, best of luck with the course. Bye-bye. Oh, how do I stop this?